All right. Building stuff has never been easier than today. All we need is an idea, and hopefully I can give you one today. I'm assuming everybody's writing more code this year than a couple of years before because of AI. Anyone reads every single line of code that AI writes? Good job. We've seen many AI presentations. This is not one of them, but take a look at this news article just from this month. A threat research team discovered an attack where credentials were discovered in a S3 bucket, rapidly escalates privileges through Lambda function code injection, moves laterally across 19 principles, abused Bedrock, and then launched instances all in under 10 minutes. The second bullet point is probably more interesting, is that it says affected S3 buckets were named using common AI tool naming conventions, which means that somebody just used AI to vibe code it. It's okay. We want people to experiment and move fast. It's a good thing. But unfortunately, not everyone is AWS expert. So we want to have some sort of guardrails to make it easy for them. And wouldn't it be nice if we could just prevent those misconfigurations? Because that's what I want to believe. That person didn't intentionally created the bucket and made it public with the credentials. It's probably a genuine misconfiguration. Wouldn't it be nice if we prevented it? But if we didn't prevent it, then couldn't we just fix it on the fly? They pushed it out and we just fixed it. That's why we have guardrails. So let's define what they are, what the guardrail is. I define them as automated controls that enforce security and compliance in real time. The benefits are obvious. We talked about security one with AI adoption, and in general, everything is moving super fast. We need automated security response. In general, we want to have an ability to respond to events in real time. Whatever happens in your environment, you want to be able to catch it and kind of do action with it. Compliance, nobody likes compliance after the fact. Again, if we can enforce compliance in real time, that will be a huge help to everyone. Teams are generally happy to do the right thing if we give them the feedback in a timely manner. And cost, it's a byproduct. Security generally doesn't go after cost directly, but that's also a nice benefit. I'll give you one example, is that with compliance policies, you have data retention policy for sure. And none of them says that you should keep the data indefinite. One of the examples is CloudWatch log groups. Most of the times you do not create CloudWatch log group explicitly. You create a Lambda, or you create RDS instance, or you create Kubernetes cluster. And let's say Lambda, you create a Lambda. Lambda is super chatty. It generates a bunch of logs. The logs go to CloudWatch log group, and that log group stays there indefinitely. The data is stored there indefinitely. That's one of the ways where you can implement the guardrail and automatically enforce the data retention on that CloudWatch log group. Best part is that if you delete the Lambda, actually, because you didn't explicitly create CloudWatch log group, for example, is that you delete the Lambda, but the log group stays. So that's one of the examples of the guardrails and something to look in your environment. I can guarantee you that you have log groups that are years old and storing terabytes of data. That's something you can fix by enforcing compliance and save some money. So guardrails is not one thing, it's a set of tools. You pick the right tool for the job. AWS has probably dozen different organizational policies, different types: service control policies, declarative policy, resource control policy, S3 policy, tagging policy. If you can, use the org policies. They are the easiest ones to implement. They're the broadest ones, but because they're very broad, you also can't always use them because of specifics in your environment. Everything that we'll talk about today relies on CloudTrail being enabled on the org level. So again, one of the examples of something to do on the org level that helps kind of general security posture in your organization. Infra as code is very important. it's much easier to give developer feedback in the CI/CD pipeline. So when somebody is using Terraform or CloudFormation template or whatever to push the code changes, it's so much easier to give the developer feedback right there, right then in the CI/CD pipeline, for example, than going after the fact and trying to fix the resource later. I think of it as like if all fails, then you go to the event-based automation that we're gonna talk about. Before you build stuff, it's always fun to build stuff, but take a look at the existing solutions. AWS recommends AWS config for a lot of this stuff. Unfortunately, you see a $ at the end. If you really want to get to real-time remediation, you would want to enable config with continuous recording. And in our environment, at least because of the size and how frequently we change the resources, that was just cost prohibitive, to put it mildly. The second one, Security Hub, also relies on you being Security Hub customer, which is not always the case. But do take a look at that repo. They have a lot of code examples for how to remediate specific event types, kind of specific findings. Last, Cloud Custodian, great open source tool. If one thing you take from this talk is probably take a look at the Cloud Custodian. Has YAML-based rules. It works across all cloud providers. Great tool. At the time when we were doing this, it had some weirdness with org-wide deployment. So we do not use it for real-time remediations, but we still use it on a schedule base. Like if you have something in mind that you want to just find in the existing environment and remediate it, Cloud Custodian is a great solution. So our solution is not totally kind of new. This is something that this second bullet point security response tool is doing. The idea is that you forward all the events that you're interested in to a central place. You analyze those events, and then you take action. In this case, anything that happens in AWS generates a CloudTrail event. All you need to do is where the number one is that you need to specify the events that you're interested in, forward them to your central event bus, and then take action. The reason why number one starts there is that because CloudTrail goes to EventBridge by default, you do not have to set anything up there, and CloudTrail also goes to EventBridge for free. So again, you don't have to pay anything for it. Really, what you're paying for is from number one to number two, and because you're only forwarding selected events, the cost is very cheap. From the arrow from lambdas going up back to your member account. So in general, you have member accounts at the top. So that's every single account in your organization, and we call it security tooling. This is where we just have all of our tooling. So from every account, from every region, you forward events that you're interested in to your central account, and then you just have Lambda functions analyzing those events. The arrows up from Lambdas up that have a Cloud Control tag on it, that's the kind of the most important piece. That's a secret sauce. Anyone use the Cloud Control APIs in AWS? I see one person nodding. Okay. Cloud Control API, think of it as a CRUD operations for cloud resources. If you use Terraform or CloudFormation, all of those work on a CRUD. So it boils down to create, update, delete list. In this case, it's like get, create, update list resource. It standardizes the verbs for the operations. This is the top one is an example of the classical AWS CLI, and you can see the verb inconsistency. You can see when you're trying to script something and when you're trying to do something, you would need to know those different verbs. You describe log bucket, but then get bucket version, and then describe, and then get again. It's very inconsistent. And the same thing with the flags after that. It's like -- log group, -- bucket, -- group IDs. Just inconsistent, very kind of difficult to code. The bottom part is the Cloud Control API example. And you can see how it is much more standardized, where You just have a type name, you specify which type, and then identifier is usually just the name of the object that you want to manipulate. Same thing with the update commands. Again, the top portion says shows an example of the traditional CLI, and the bottom is with the cloud control. The lines are split a little bit, and that patch document seems intimidating, but in fact, it's just manipulating the JSON object that you get back that describes the object. So when you look at it, it follows the same CRUD operation. So add, update, or delete a certain value from the JSON. And the same pattern gets across to code. This is what kind of obviously simplified example, but this is what you would use in your Lambdas for validation or remediation. When you get an event that you're interested in, all you really need to do is call Cloud Control API, and you can see that you really just substitute a couple of parameters. On the line 4, you would traditionally initialize client for every single service. So you would do client EC2, client S3, every type of service that you want to interact with, you would have to initiate a separate client object. And then all of those inconsistent verbs, again, you would have to write separate functions to make those calls, which make coding a little bit harder to scale once you go after more and more use cases. With the Cloud Control API, the code is standard. The only thing you're substituting is line 7 and 8, right? So you're just specifying which resource you want to kind of check, and then the name of that resource. And about the same 10 lines of code for if you want to manipulate the object. You would just substitute line 15, type, identifier, and then the patch object that you want. But it's really a super nice template. Back to the diagram, let's focus on what we call validator function. Why does it even need this Cloud Control API and like assume role into a member account if we have everything in the CloudTrail event? Well, the problem is really inconsistency. That sometimes I call it the happy path. Sometimes a CloudTrail event indeed has everything that you need to do to respond to an event in real time, but there's a lot of times that it doesn't. So in this case, you can see that this is an example of the authorized security group ingress when you're modifying security group in AWS. And CloudTrail itself, right there, has everything that you need to do. So in this case, we're just catching when somebody is trying to authorize a security group with any port, any protocol from port, and to port are any. -1 means any. And at the bottom right, you will see an example of the rule that we write. And we use actually a rule engine, and you see the link at the top if you want to take a look. Rule engine lets you just write rules against any JSON object. And this is one of the more complicated rules because we're trying to catch multiple ports there. And this is a truncated example. But you see, if you were to try to catch when somebody is trying to open port 22, RDS admin ports and stuff like that, you would just list all of those ports in the array, and then this rule would automatically tell you when somebody is authorizing an ingress with those ports being wide open from like quad 0. This is not a happy path. So you get an event from CloudTrail, and it says somebody created the CloudWatch log group or S3 bucket or whatever, and you can see that all this event has is the the name of the event and then the name of the resource. But the actual configuration event comes seconds later. And that doesn't work because in this case, you actually, you need to stitch those together in real time and requires building a complex stateful event correlation engine. We didn't want to do that and we just wanted to keep it stateless. So the way we do it is that we just use the initial create notification event. We take all of the information from here, like the event name and then the actual resource name, and then we call Cloud Control API here to go assume the read-only role to the member account, look at the state of that resource, because we don't know if that configuration event came in later and what the configuration was. So we just kind of ignore most of that stuff, and we just take the information that we need from the create event, and we immediately go back to the resource and just check the state of it, and then we run the rule against that output to see if it matches our kind of standard. This is an example of just running it in CLI. You can see this is how you would get the state of the CloudWatch log group, and the rule using the rule engine is super simple, because if retention is not set, then you would just not have that key, JSON key, in the response. So our rule is actually just not retention in days. If that key is absent in the JSON blob, then this is a matching rule. And we would go and then patch that object and add retention in days to that. You can see there's 2 more examples of the Kinesis stream and Kinesis firehose. This is a simple example of where we do sort of like a compliance thing of just adding encryption to those Kinesis stream and Kinesis firehose. Again, security and compliance at the same time. Testing is super important. Just a simple slide that every time you write the rules, we have a simple YAML file again. We're simulating passing different JSON objects to our kind of rule engine and expecting it to either match or not match. Now, if we put it all together, really, when you look at the diagram on the right again, and everything that we really need to configure, and think about simplified 20 lines of code of getting the state of the resource and then patching it, really all the information that you need is in this YAML document that we came up with. It's just a simple schema, and we're saying that really on number 1, where we are interested in a particular event types, we write the rule and we specify which events we're interested in. So on the line 32, 33, we're just saying this particular rule works on a create log group event or create S3 bucket, whatever the case. Then you can just have a simple script that parses all of your rules and gives you exact list of events that you're interested in, and then you can plug it into the CloudFormation template and deploy it to your org. Same thing with the remediator Lambda. You do not want to give that Lambda just admin privileges across all of your resources. We just put it right in the YAML. All that Lambda really needs is the put retention configuration, for example. The same thing would be with S3 buckets and any other resources. You're just giving it bare minimum permissions that it needs to remediate the resource. The top portion is the documentation. So this YAML is not only a configuration for the Lambda, it's not a configuration for the event bridge, it's all of it. It's a low-code kind of approach to write rules. Next engineer that comes in, they want to write a next rule. They fill out the documentation portion. We use mkdocs automation, mkdocs library from Python. We parse it, we build a web page, and it automatically publishes for everyone to see what the definition of the rule is, what the guidance is. So this YAML is everything. It's a documentation, it's CI/CD, it's configuration. So is it really that simple? Just 20 lines of code and you get it all done? It probably never is. Don't get me wrong. Like I said, for a lot of the use cases where you just have a simple flag of set retention, set encryption, set something simple, it works great. You can automate a lot of the use cases that way. But there is some things that you need to think about. Exception handling, just like everything else, there's very few things that are just black and white. There's sometimes exceptions. What we do with exceptions is that even if it's a public S3 bucket, for example, there are legitimate use cases when people need S3 bucket public. You're hosting a website out of S3 or something like that. So we are doing exceptions based on tagging. In that YAML file, we also have an exception tag that says if you need an exception, you just specify the tag with this specific value, and then it's going to go through our guardrail will bypass it. So think about that. Slow resource provisioning Again, if you want to get into more of a complex use cases, for example, you want to check the state of your RDS instance or Kubernetes cluster, you will get creation event super quick from CloudTrail. However, the RDS instance takes time to come up. Therefore, when you run the call to get configuration and check for the compliance, you won't be able to until RDS is ready. So we use like a step function. Step function? Yes, I think so. It gives you a back-off algorithm where it can wait a little bit longer. Your Lambda can pause and wait until the resource is ready, and then you get the state of the resource. And unfortunately, this cloud control is not perfect on its own. One example is that sometimes the traditional CLI gives you an ability to update resource, whereas cloud control would do it with delete and create. There is a very few examples where this causes problem because the resources are linked using ID. So if you actually delete it and recreate it, it may cause some confusion depending on how developers are building it. So just pay attention. It's all listed in a documentation. You will clearly see if API lets you update or if it will kind of tear it down and recreate it. And last is the really annoyance with AWS API or CloudTrail, I guess, is that it's inconsistent API response. For some events, in the name of the resources, you will actually get the name of the resource, and the other times you would get the ARN. So it's just confusing. I don't know why AWS does it, but it is what it is. So there's some gotchas that you need to pay attention to. But really, this is a low-code approach to build a couple of those guardrails. Super quick takeaways. Better to prevent than remediate. We talked about it. Use the org policies, use account level settings, use stuff that prevents the misconfiguration from going in versus fixing it later. That's always better. Cost. This solution is really super cheap. You run this for dollars versus if you enable AWS config, that's going to cost you a lot. And then a couple of examples of guardrails. I took CloudWatch as a super simple example people can relate to. Duplicate CloudTrail is really a fun one. I mentioned that CloudTrail goes to EventBridge by default. That is true. And AWS gives you CloudTrail for free, but only the first CloudTrail. If your developers are, for some reason, configured a duplicate CloudTrail, then you're going to start paying for it. So take a look. It's a fun one. Your CloudTrail bill should really be 0. But if you're paying thousands of millions, you're probably looking at some duplicate configurations. Again, something super simple to build a guardrail for. And then public resources, a bunch of examples. Most of those are a simple flag, public or not public. Again, good candidates for this type of guardrail. KMS encryption, same thing. And then something simple like catching a trust policy with a principal star could be one of them. Otherwise, analyzing IAM is super hard. Yeah, I think that's it. Thank you very much. Yeah, so the question is Boto 3 example versus cloud control. This is the reason, because when you use Boto 3, you would, in the code, you would have to initialize and, so where was it? Here. So in Boto 3, when you write the new use case, on the line 4, you would need to initialize all of the resources differently. You would initialize the client for EC2, and then on the line 6, instead of doing get resource, you would do, update S3 bucket, but then you would have to initialize the code different functions for every single resource. Versus this, it's a really simple template. All right, thank you very much. Have a good day.